Hello everyone, this is Darshani from CSC Aryabhatta. Today my subject is maths and today topic is Markov chains. The presentation explores fascinating world of Markov chains, providing a comprehensive overview of their core concept, properties and applications. Transition matrix, navigating the probabilistic landscape. Transition matrix. Transition matrices are the art of Markov chain, capturing the probabilities of transitioning between the different states. Each entry in the matrix represents the probability of moving from one state to another. Probability distribution. The probability distribution describes the likelihood of being in each state at given time. We can use the transition matrix to calculate the probability distribution at any further time point. Regular Markov chain, a world of predictability. Regularity. Regular Markov chain are characterized by transition matrix where all elements are positive, meaning that there is a positive probability of transitioning between any two states. Long-term stability. Regular Markov chains exhibit long-term stability where the probability distribution converges to a unique stationary distribution regardless of initial state. Stationary distribution. Definition. The stationary distribution of a Markov chain represents the long-term probability of being in each state where the probabilities remain constant over time. Properties. The stationary distribution is independent of initial state. It satisfies a key equation where the distribution multiplied by the transition matrix is equal to the sum of distribution. Calculating the stationary distribution. Linear algebra. Facing the stationary distribution involves solving a system of linear equations derived from transition matrix and the properties of stationary distribution. Numerical methods. Numerical methods like power iteration method are used to approximate the stationary distribution it iteratively the transition matrix using the convergence. Existence and uniqueness. Regularity. Regular Markov chain guarantees the existence and uniqueness of a stationary distribution as transition matrix ensures positive possibilities of all states. Ergodicity. Ergodic Markov chains, which include regular chains, also ensure existence of uniqueness of stationary, incredible, stable, long-term behavior. Observing states, the ends definition. The observing state is a state where system remains once it enters with no possibilities of transitioning to any other state. Characteristic. Observing states are characterized by a self-transition probability of 1, meaning that the system remains state with 100% certainty. Identifying the observing states. Transition matrix. Observing states are identified by examining the transition matrix. A state is observing if its corresponding row has only one on the diagonal represents a 100% probability of staying in the same state. State analysis. Directly analyzing the properties of each state in another method. If a state has no outgoing transition, to ongoing states, it is considered as observing state. Transition and recurrent state. Transient state. The transient states are states that the system can eventually leave and will not return to. They have a finite probability of reaching an observing state. A recurrent state. The recurrent states are the states that the system will return to infinitely often, meaning its probability one of returning to them. Observing states are also recurrent states. Markov chain. Conclusion and key takeaways. Transition matrix. The transition matrix is a cornerstone of the Markov chain, defining the probability of transiting between two states. Second one, stationary distribution. The stationary distribution represents the long-term probability of being in each state, often insights into the stability of the system. Observing state. The observing state acts as a final destination, capturing the system's long-term behavior and influencing the dynamic of transition. The main key concepts of Markov chains are transition matrix, stationary distribution, and observing states. In this, it is all explained and given. Thank you.